without using a calculator, find the value of 6 power x, given that 3 power x plus 2 equals to 12 power 2 minus x. Take note that we are not trying to solve for x. Not solving for x. Okay, so don't go and try any logarithms over here, find the value of x, then substitute over here, because that's not what is supposed to happen. So let's take a look at the equation. 3 power x plus 2 equals to 12 power 2 minus x. The question wants 6 power x only, so we see that the powers over here can be separated using our laws of indices. Let's see how we can separate them. From 3 power x plus 2 equals to 12 power 2 minus x, we want to end up with just something power x. So let's split this up. 3 power x times 3 power 2 equals to 12 power 2, 1 over 12 power x. Okay, now we are going to group all the x terms together. We do so by multiplying by 12 power x on both sides. So 3 power x, 12 power x, and we have 12 power 2, and we are going to divide by 3 power 2 on both sides. 1 over 3 power 2. Now 3 power x times 12 power x, both of them have the same power. So we can multiply the bases together. 3 times 12 is total of 36 power x. They share the same power. On the other side, 144 divided by 9 is 16. So now we are getting closer and closer to what was required, which is 6 power x. However, instead of 6 power x, I have 36 power x. And you have to recognize that 36 is a perfect square. It is actually 6 square. Okay, so another way of writing 36 will be 6 square. And all this power x equals to 16. Okay, this is just an arrow to tell you that we are dividing by 3 square on both sides. We are multiplying by 12 power x on both sides. Right, so now I only want 6 power x. But this is 6 square power x. You should recognize that this is the same as 6 power 2x, which can be written as 6 power x square. They mean the same thing. And this is 16. At this point in time, I only require 6 power x, but what I have is 6 power x square. So to get rid of the square, I need to square root both sides. And when you are introducing the square root, you have to remember there is a plus minus sign. Okay, so now we have two answers for 6 power x. Let's see whether both of them are reasonable. The graph of 6 power x. Okay, even if you don't talk about the graph, you try any value of x you like, you will get a positive answer. Any value of x you like. You will never ever be able to find a value of x such that 6 power x gives us negative. Okay, because we can look at it from a pattern. For example, 6 power 3, that is 6 times 6 times 6. 6 power 2, 6 times 6. 6 power 1 is just 6. 6 power 0 is just 1. 6 power negative 1, 1 over 6. 6 power negative 2, 1 over 6 times 1 over 6. And so on and so forth. No matter what the power is, we will always end up with a positive value. It is either going to be a very small value or a very large value, but they will never be negative, even for negative powers. Okay, that is why we reject negative 4. Questions? Next question is 5. Okay, so here we have variables x and y. They increase in such a way that when x equals to 2, so these are the keywords, when x equals to 2, the rate of increase of x, okay, so rate of increase of x, that means dx over dt, when it is, okay, they mention with respect to time, so dx over dt, this is, so the word is, put an equal sign, is, yes, huh? Yes, it is. Dx over dt is, so we put an equal, is twice, so 2 times of something, 2 times the rate of increase of y with respect to time again. So dy over dt. So this is interpreting the second part of this sentence, but with a key phrase over here, when x equals to 2. So it is not true that for all time, dx over dt is double dy dt. It is only true when x equals to 2. So now they also gave us another piece of information, y equals to k root 4x plus 1. K is a constant. K, 4x plus 1 power half. So we would like to rewrite that because it will be easier for us to differentiate. Where's the differentiation? Why should we be differentiating this? Okay, because at the moment we have dx dt, dy dt, but the equation given has no time. There is only y and the relationship with x. So over here, time is what is linking x and y together. Both x and y are dependent on time. But in this equation, time doesn't appear. So for this equation, we can differentiate y with respect to x only. We can't differentiate it with respect to time. So let's see what happens when we differentiate it with respect to x. Copy down the coefficient, copy down the power, copy down whatever is in the power, whatever is in the bracket, reduce the power by 1, multiply this by differentiating the bracket. Simplify everything, we get 2k over 4x plus 1 root. So this is our dy dx. So we've got dy dx, we've got dx dt, we got dy dt. It should ring a bell. What is the next step? Okay, the next step is that we're going to be using chain rule. We're going to link dy dx with dx dt with dy dt. So our chain rule will look like this. Dy dt is equal to dy dx multiplied by dx over dt. You have to recognize and be able to write this by yourself. In a way, it looks like dx and dx can cancel. Looks like it. So we're left with dy dt. Okay? So we're now going to substitute whatever we have. Dy dt, we don't have an expression for dy dt, so we leave it as it is. Dy dt. Dy dx. Okay, we have an expression for dy dx. Let's copy that down. 2k over 4x plus 1 power half. So we've rewritten dy dx already. Multiply this by dx dt. Do you have an expression for dx dt? Yes, you do. From the question, they said that dx dt equals to 2 dy dt. But there's a condition. It is when x equals to 2. So we're going to replace dx dt with 2 dy dt as well as write down the condition. So dx dt is 2 times dy over dt when x equals to 2. Okay, since we mentioned the condition, we should substitute the x over here with 2. Because that is when it is true. Let us replace that, this 4 with a 2. Okay, let's simplify. So dy over dt is 2k, 9, square root of 9 is 3, 2k over 3 times 2. So let's change this to become 4. 2 times 2 is 4 times dy over dt. Okay, now let's take a step back. observe this equation, dy dt equals to 4k over 3 times the same dy dt. We see that dy dt appears on both sides. So we can divide by dy dt on both sides, isn't it? Divide by dy dt on both sides, we're left with 1 equals to 4 over 3k. Now I have one equation with only one unknown. Therefore, k must be equals to 3 over 4. Look at the number of steps there are. Not a lot. They're testing you on all the concepts that you need. Question 7. Binomial. The coefficient of x in the expansion. Now the first expression over here is linear. There is nothing to expand. But in the second expansion, in the second expression, this will be our binomial. Okay? This, when expanded, will give us 6 choose 0 times 1 power 6 times ax power 0. This is our first term of the binomial. Yes, TR plus 1 is the general term.
So can I just write the first line, TR plus 1 equals this?
Can.
And we get mark 4?
No. TR plus 1 is fine. Okay, so the next term, 6 choose 1, 1 power 5, ax power 1, plus 6 choose 2, 1 power 4, ax power 2, plus so on and so forth. So if you notice, a quick recap, the pattern over here is that all the 1 power something, they will remain as 1. 1 power 6, power 5, power 4, 3, 2, 1, 0. You actually didn't have to write them down. Okay, let's remove them. What else do we notice? The coefficient. 6 choose 0. You can use your calculator to find out if you want to. But that will be 1. 6 choose 1 is 6. 6 choose 2, 15. What else do we see? This is ax power 0, which means it is 1. Here we got ax power 1. This is a square x square. So we see that the x power is increasing as we continue expanding. Okay? We can continue, but all I wanted you to do was to remember the pattern, what we are expecting. Because that is sufficient for us to do part 1, to find the value of the constant a. Okay? So now, the expression on the right looks like this. 1, I'll simplify it to become 1 plus 6 ax power 1 plus 15 a square x square and so on. In the expansion, 2 minus 3x, 1 plus ax power 6. We'll rewrite this to become 1 plus 6 ax plus 15 a square x square plus dot dot dot.
So sometimes I'm not sure how many numbers I should expand. Then I sometimes get confused whether I should expand just 4 terms, the first 4 terms, or like just expand all.
It depends on the nature of the question. In this case, they are asking for the constant a. When will we get a constant? See, over here we are multiplying a linear expression with a binomial. The binomial is expanded. I only used 3 terms because I know in order to obtain a constant, it will happen by multiplying a constant with a constant. Okay. They want the value of the constant a. They are not asking for the constant term in this expansion. They tell us that the coefficient of x is 3. Coefficient of x. So when do we how do we expand and obtain an x term? Constant times x, yes. So a constant multiplied by x term. This is one of the x term. Is there going to be another one? Can there be another one? Yes, there will be another one. It is found here. Another constant multiplied by another x term. So you have to visualize by yourself the rainbow if you were to expand everything out. The only way for us to get an x term over here is if we take a constant times x. And then there is another pair, constant times x. So let us write down what we expect the x term to be. X term. The presentation can vary over here. As long as it is acceptable, we will give you the mark. So the x term will be 2 times of 6ax plus 1 time of negative 3x. So we have 12ax minus 3x. Simplify this to become 12a minus 3 multiplied by x. So in the question they say that the coefficient of x, this is our x term, is 3. Therefore, 12a minus 3 has to be equal to 3. 12a is 6, a must be half. In part 2, to find the coefficient of x squared, so we go back to our partial expansion. In order to get an x squared term, these are the possibilities. We have a constant multiplied by x squared term. We can also have x term multiplied by x term. And we don't have any more options already. Because in the first expression, we only have x power 1 and x power 0. So use the same format. X squared term is equal to 2 times of 15 a square x square plus 6ax times negative 3x. So here we have generated the two x square terms. So this is 30a square x square minus 18a x square. We can substitute a, which is half, in right now. So half square x square 18 half x square. Simplify. Negative 3 over 2x squared. So here is our x squared term. They will ask for the coefficient of x squared. So you still have one last line. Coefficient is negative 3 over 2. So 6 marks over here. Can I move on? Question 8 on modulus. Now class, please take note this symbol. This symbol over here with the lightning. Do you know what it means? Do you know what it means? It means not in syllabus. However, it is quite misleading because modulus is not in syllabus next year. Okay? If a Sec 3 student uses your TYS that you just bought this year, then it makes sense. They just skip this question. But for you, it is still tested this year. So we still do this question. Okay? Whenever you see this lightning symbol, you just do. Unless you really think it's out of syllabus, then you check with me. Like some of you have done. Okay, so here we have a modulus graph. Find the points A, B, and C. This is the graph of y3 minus 2x plus 1 with modulus. Some features of this graph. Okay, everybody please look up first. Or look up, stop your work. Look up, look up. some features of a straight line graph with modulus involved. This vertex over here, this particular point, will lie in the middle. It is symmetrical, it will lie in the middle of the two x-intercepts. So if I find the two x-intercepts, I can take the midpoint to find point x coordinate for B. Then do the substitution to find the corresponding y coordinate. Okay? That's the point that I wanted to make. You can resume your work. So it is easier to find the points A and C first. Then we find point B. Okay? So at points A and C, y equals to 0. Because they are on the x coordinate. So our equation, 3 minus 2x plus 1 equals to 0. Now we are solving a modulus equation. 2x plus 1 equals to 3. So as mentioned, whenever you are solving modulus equations, just know that there are two possible paths that we can take. The first path, just remove the modulus. 2x plus 1 equals to 3. Or, in the other case, 2x plus 1, on the other side, put a negative sign. So we change the sign on the right hand side. We end up with x equals to 1, or x is negative 2. So find the corresponding points negative 2 and 1. And the graph makes sense. We have the negative value, which is larger in magnitude. It's more towards the left than the right. So now we expect, now we can write down point A is negative 2, 0, point C, 1, 0. And now we expect point B to be a negative number, the x coordinate for point B to be a negative number right in the middle of negative 2 and 1. So the midpoint x coordinate of B is the midpoint, negative 2 plus 1 divided by 2, which is negative half. Substitute in to the equation. Y is 3 minus modulus 2 times of negative half plus 1. 3. Inside the modulus, we have 0, which makes sense. 2 times negative half is negative 1 plus 1, 0. Okay, so 3 minus 0, which is 3. So now our B coordinate is negative half, 3. So 3 sets of coordinates done. Okay, now there is another way to find the coordinates of B over here without using midpoint. But we will have to use some arguments to determine what B coordinates are.
Is that what the answer sheet did?
I do not know what the answer sheet did.
The answer sheet just plot the answer out the way.
Okay, I will show you. Okay, then probably that's how they did it. Okay, so everybody please look out again. This is another skill that I expect you to be able to have. So this is the graph of y equals to 3 minus modulus 2x plus 1. This point B is the maximum point. It is the largest value of y. Okay? So look closely at the right hand side. The right hand side is made of a tree. Take away something. Okay, the tree is fixed. It's fixed there. You always have to take away something. When you take away something, the final value becomes smaller, right? You take away something, it has to become smaller. But now our goal is to find the largest value of y. So if I want the largest value, what should you take away? Do you want to take away a big value or do you want to take away as small as possible? You want to take away as small as possible in order for your result to be as big as possible. Make sense? So we want to take away as small a value as possible. So what is the smallest value of modulus 2x plus 1? 0. There we have it. We want this to be equal to 0. And when is this equal to 0? X is negative half. So we have the x coordinate of x equals to negative half already. And when you take away 0, of course you must be left with 3. Okay, so that is how you can also do this with just one step.
So that's the one the answer sheet is.
Okay, then you must understand what they are talking about lah.
Yeah, the things I didn't.
Okay, now you know. Final part, solve another modulus equation. You really cannot have a fear of solving modulus equations because it is exactly the same as solving any other equations, just that the first step, you have to break it into 2 parts, and that's it. Okay, so do not have a fear of solving modulus equation.
So, is it correct to say that if I write modulus and break it into 2 parts, like, can I put bracket 1 with negative and 1 without negative?
Yes, then it will be the same. It is the same thing. So 3 minus modulus 2x plus 1 equals to x. You can make the modulus the subject first if you're more comfortable with that. So modulus 2x plus 1 equals to 3 minus x. From here, we break it down into 2 different parts. Ignore the modulus, that's it. 2x plus 1 equals to 3 minus x. That is one possibility. Now the other possibility is just copy down 2x plus 1, and on the right hand side you multiply by a negative 1. Okay? It is the same as removing the modulus and changing the sign in the modulus. It's the same thing. So on this side, negative 3 plus x. These are the 2 equations that we will be solving. And at the final step, we just need to check whether both answers make sense. So here we have 3x equals to 2. X is 2 over 3. The other possibility, x equals to negative 4. Okay, so at this stage, we have to substitute both of these values into the original, into the original equation over here to see whether it is correct. So now, checking. Sub x equals to 2 over 3. So 3 minus 2 times of 2 over 3 plus 1. This is the left hand side. Is 3 minus 4 over 3 plus 1, 7 over 3. 3 minus and we get 2 over 3, which is equal to the right hand side. Okay, so I know that this is definitely acceptable. The other possibility, x equals to negative 4, left hand side, 3 minus 2 times of negative 4 plus 1. 3 minus, this is negative 8 plus 1, negative 8 plus 1 is negative 7. So 3 minus positive 7, we get negative 4, which is equal to the right hand side. So here, both answers are acceptable. Okay, please don't forget the last checking step. Sometimes left hand side will not be equal to right hand side. One last question that was identified, question 13. On trigonometry, we can expect a problem sum like this, where you have to understand and interpret the sentences. OA is hinged at O, so it can rotate. This is the pivot. It is a 5-meter rod. Now, AB is another rod with another pivot. So both of them can rotate. They give you an angle over here, theta. It is between 0 and 90. The rod AB also can turn. And they have another condition. This will be the same angle theta. Will be the same. They give you the length. They gave you a height over here. And you have to find the expression for the height. Okay, so this height, H, is made up of 2 parts. H is made up of 2 parts. First is from the triangle, the smaller triangle on top. So if you were to draw a right angle triangle, BA3, this being theta, we will be using sine. theta is this short length over here. Let's call this point M. Bm over 3. So Bm is 3 sine theta. We do the same for this triangle. Let's call this P. So for a big triangle, P, A, and O, this being theta, this is phi. Alternate angles, parallel lines, this is also theta. So now, we want AP. We're going to be using cosine. Cosine theta is our adjacent, which is AP over 5. AP is 5 cosine theta. So now we have expressions for both heights. The first on top, it is 3 sine theta. The one below, 5 cosine theta. All of these, both of these add up to become H. So H is now, put it in the form that we want, 5 cosine theta plus 3 sine theta. Find the values of the integers. So you need to state A equals to 5, B equals to 3. Now using the values, using our R formula, we rewrite this to become R sine theta plus alpha. Now our first term is a cosine. Second term is a sine. The R formula wants it to be a sine. So switch them over. Now our H is 3 sine theta plus 5 cosine theta. So that we can apply our R formula, which is equal to root 3 square plus 5 square sine theta. The sign doesn't need to change. Okay, if it is a plus, it remains as a plus for sine. Then we have tangent inverse 5 over 3. This is our R form. So end up with root 34 sine theta plus tangent inverse 5. Make sure you are in degree mode since they are using degree. So 78.690 degrees. Is that correct? Question 13. Why is my value wrong? Oh, 5 over 3, not 15. Inverse tangent 5 divided by 3. So 59. Okay, now, since it is not exact, we will leave it to 1 decimal place for degrees. Root 34 sine theta plus 59.0 degrees. Part 3. So part 2 done already. Part 3. State the maximum value of H. H, we already have another format. H equals to root 34 sine of theta plus 59.036. The maximum value of a sine graph is 1. So maximum H is root 34 multiplied by 1, which is root 34. Okay, our sine graph looking like this. Maximum value 1. And find the corresponding value of theta. So when the maximum value is 1, the angle is 360 divided by 4, 90 degrees. It happens when theta is 90 degrees. It happens when the angle is 90 degrees. So when theta plus 59.036 equals to 90, So theta must be 90 minus 30.963. So round it off to 1 dp, 31.0 degrees. Okay, part 4. Find when h equals to root 17. So root substitution, root 34 sine theta plus 59.036. Make theta the unknown. So we're left with sine theta is root 17 over root 34. You have to recognize that this is root 2 over 2. And this is a special angle. This will result in a special angle. So theta plus 59.036, we have 45 degrees. In the first quadrant or second quadrant, 180 minus 45 degrees. So continue solving and get the answer.